the way, the date of the exam, I just sent you an email. It's the first day of the exam. It's the 13th of January, Monday, 9 a.m., 9:45 a.m. Check your emails, guys. Okay. That's the first day of exam, so you can have it done. Alright, so as I said, I'll be in Manchester throughout the Christmas break and also until the date of the exam. So any questions you have about the exam, you can ask me. Okay. So any questions you guys have? Any particular questions you like me to do? Like say from the past exam papers? Do you have any particular questions? There will be eight questions in total. I sent you an email anyway, so I don't need to explain it again. But there will be 8 questions in total, and there will be 2 sections, section A and section B. You have to do 2 questions from section A, and 4 questions from section. Well, yeah, 4 questions from section B. So in total, you have to do 6 questions out of 8. Okay. So let me come around and ask you guys any questions you want me to. How are you, sir? You look happy all the time. How are you? All right. How are you guys? Where's your friends? They haven't come. Only 1, 2, 3, 4, 5. Now there. What's happening? So there's 5 here. Only 8. Only 8 people. Come on, guys. Give me some questions you want me to do. I will do it. All the past exam papers are on the course website. I'm sure you know where to find them. You have some questions? No. What about you? Do you have questions? No? So this is, I printed out the past exam papers. So this is, let me show you. This is question. This is question B5 from last year's exam paper. And can you read this, guys? One. So basically you have portfolio is made up of K investments. K is known. Suppose that the losses of the investments x1 to xk are dependent on the variables with the joint survival function. Lambda as a parameter, unknown parameter. Okay, let's see how we can do this. So this is question B5 from 2000. Okay. Now, part A, We want to find the cumulative distribution function of V, which is the minimum of x1 to xk. So we want to so V is the minimum okay. You want to find the CDF of V, right? Okay, and this we can write as 1 minus the probability. Okay, like this. Okay. And this is 1 minus the probability that okay, right? Okay, what's the next step, guys? What is the next step? Tell me. If the minimum is greater than little v, then each of these x's has to be greater. Okay? So this would be okay. Oh yeah. Are you with me, guys? Yeah. And this, by the definition of the joint survival function, what you have here is f bar like this. Okay. Remember, the joint survival function f bar is defined like this. Okay. So this will be exponential using this formula here. Like this. Okay, so this would be 1 minus exponential of minus kV minus lambda. So this is the, so did you guys follow this or no? That's part A. So if you came late, we are doing question B5 from the last year's exam paper, part A. Okay. Okay, this is B5 part A of last year's exam paper. Any questions on this, guys? This is clear to all of you or not? Yes. Your answer. Yes. All right. So that's part A. Part B is to derive the corresponding probability density function of V. So to do, I'm going to do that now. So let me put this over here. Can you see this, guys? Okay, this is part A. Part B is to find the probability density function of V. So the PDF of V is, as you know, is the derivative of the CDF of V. Alright, so if you differentiate this guy here, if you differentiate this with respect to V, you get k plus lambda this is what you get. Alright, that's the PDF. So that's part C. Okay. Part C, this is clear, guys. I mean, it's just straightforward. You just derive, you differentiate the CDF to find the PDF, right? Part C is to find var, alright? To find var, all you have to do is set the CDF, you set which implies that exponential of and this implies that V is equal to minus 1 over k plus lambda log of 1 minus p. So hence the var is equal to this. Alright, so this is part C, right? Any questions on so far, guys? Yes? No? No questions, guys? Come on, guys. Talk to me, guys, please. So this is your value at rest, and that's part C. Part D. Part D of is to find the expected shortfall of V, right? So I'm sure you guys know the expected shortfall is one over p times the integral from 0 to p of minus 1 over k plus lambda times log of 1 minus t dt. Okay, and this you can write as you can write like this. Okay,
Now to do this integration you can apply parts, integration by parts. So if you apply integration by parts to this, you get t okay, and then in brackets we have minus, actually minus minus will become a plus, so you have the integral from 0 to p of t divided by 1 minus t dt. Okay, this is what you will get. Okay, this is a product sign case, so this will be minus and the limit at 0 is 0. And this guy here, you can write it like this. You can write 0 to p, t minus 1 plus 1. Okay. Okay, guys. Now I'm gonna write. The reason I've done this is because, for a reason. You can split this into two different integrals, right? First, minus 1 plus 1 divided by 1 minus. There are two different terms here. Okay. Okay, and so if you do the the integrals of both terms, you get the integral of minus 1 is minus t. The integral of 1 divided by 1 minus t is minus then you take the limits from 0 to p. Okay. So finally, the limit at p is minus p minus log of 1 minus p, and the limit at 0 is 0. So this is the answer. Alright guys, so this is the formula for the expected shortfall. Are you guys okay with this? Alright, any questions guys, please let me know. Okay, now the last part I would like you to do, I would give you, instead of me doing all the questions, I would just give you a few minutes. So this is part D. Now part E of last year's question is the following, that Can you guys do this, please? I'll give you a few minutes and see if you can do it. I don't want to do all the questions. So try. Can you do this, please? Part E, which I have written down here. So if V1 to Vn is a random sample on V, find the maximum likelihood estimator of lambda. Okay. Alright guys, I'll give you like a 5 or 10 minutes and see if you can do this. This is all these past exam papers are on the course website, and also plus the solutions are also on the course website. So this is last year's exam paper. You'll find it. Yeah. You guys done it or what? Hello guys. Alright guys, let me show, if you haven't done it, and I know some of you have done it already. So the first thing you should do is to write down the likelihood function. So remember the likelihood function is the product of the density function, right? So it's the product I from 1 to n of the density function which we derived earlier, you may remember. Right, this is the likelihood function, remember. Okay. Now if you simplify this, you will get this, right? And the next step is to take the log likelihood Okay. And the next step is to differentiate the log likelihood with respect to the parameter. So you get n divided by k plus lambda minus the sum of VR. And the next step is to set this to 0 and solve for lambda. So if you do that, you get this, and this, from this you get lambda hat to be okay. And the final step is to take the second order derivative, which is minus n okay, and this is the second order derivative, and this is less than 0, of course, right? Hence okay. Is that right, guys? It's not difficult, is it? So this is the answer to, so the MLA for lambda is this one here, okay? So this was last year's exam question B5. Now let's go to the previous question. This is, sorry, had you you don't need to copy this, but you can. This is question number B4. Question number B4 in last year's exam paper. Okay, here a portfolio is made up of K investments where K is known. Suppose the losses on the investments are dependent with joint cumulative distribution function given by this. Okay. Part A is to show that the cumulative distribution function of U, the maximum portfolio loss, is this, right? Can I give you 5 minutes to do this, please? Part A, if you haven't. I mean, part A of, it's not difficult at all. Okay, can you take 5 minutes and see if you can do part A? If you want, I can put it here if you want to see it better. Come on guys, practice. I mean these are the kind of questions you will get in the final exam on the 13th of January next year. Yeah, so if you practice these kind of questions, you should do fine. Alright guys, let me show you how to do the first two parts or three parts. Okay, so part A is so this is this question B4 from 2018-19 exam. Okay. So the first thing, okay, part A, we want to find the CDF of U. So the CDF is this one, yeah, which is equal to the probability that the maximum of x1 to xk is less than or equal to u. Okay. Now, if the maximum is less than or equal to u, then every x has to be less. Alright, so this is the same as the probability that x1 is less than or equal to u up to xk is less than or equal to u. Alright, and this is the same as saying that this is the joint CDF at u, right? Joint CDF of x1 to xk at u. right? By definition, I'm sure you know the definition of the joint CDF. Now the joint CDF is already given to us. It's this one here. All right, so this will be 1 divided by 1 plus I from 1 to k of exponential at minus u, right, which is the same as 1 divided by 1 plus k times exponential of minus u. All right, so this is how you will do part A. It's not difficult, is it? Are you okay with this, guys? Hello? Yeah? Okay, part B. Part B is to find the corresponding PDF. So the PDF of u is simply the derivative of this with respect to u. So you get, if you differentiate it, you get there will be a minus to the power 2, then k minus 1 exponential of minus u. So if you simplify this, you will get the following. You get k exponential of minus u divided by 1 plus k exponential of minus u squared. Okay, so this is the probability density function of u. Okay, guys? Okay, the next part C is to find the moment generating function. I didn't do that, but I mean, this is stuff you should know from your undergraduate degrees. I mean, from your undergraduate, if you don't know that, I mean, a moment generating function is basically if the MGF of u of any random variable is defined by the following, which is m is given this notation here, mu at t, and is defined as the expectation of exponential at t u. This is the definition. This is the definition of the MGF, or the moment generating function of any random variable, right? Okay. So okay, let me continue this. So for this for this particular question, this will be the integral from 0 to infinity. Oh, not 0 to infinity. I mean minus. So I should say minus infinity to plus infinity of exponential of tu, right, multiplied by the density, which is right. So you need to work this. Do you see how I got this? This is the term that you're trying to find the expectation of, and this is the density function we just worked out. This is the density function of u, right? Right. Now the next question is how to. The limits of integration come from this. You see, if you look at the question, the limits go from minus infinity to plus infinity. So the limits of u must be from minus infinity to plus infinity. Alright, so this is the integral that you need to work out. Okay, and to do this integration you need some kind of substitution, and I mean, as I said before, substitution is something you learn by experience. So in this case, the substitution that I will choose will be the following. Will be, let me show you. The substitution I will choose will be the following. Set set x equal to this, right? So I mean, this is once again, I mean, why I chose this is because I mean, there's no reason. It's because again, it's something you have to learn this by experience, by doing lots of questions. So this will be 1 plus k and this implies that okay, and this implies that u is gonna be minus log of this is your u, and in other words, u is equal to minus log of 1 minus x plus log of k plus log of x. Okay, that's what you get. So du by dx will be 1 divided by 1 minus x plus 1 over x, which will be 1 divided by 1 minus x times x. Okay. All right. So this is. So let me put this inside a box. Right. So this is. Because I chose this substitution because I know from my experience that this will work. Right. Okay. So this will become k. All right, the limits of integration, when u is equal to plus infinity, this will be 0, so it will become 1. And when u is minus infinity, this will be 0, right? And then the guy at the top will be, which is exponential of minus u to the power, let me see, just give me a sec, exponential of minus u to the power 1 minus t, so it will be just give me, you substitute exponential of, so exponential of t minus 1 or 1 minus t times log of 1 minus x divided by kx, right? And then you have to multiply that by x squared, and then you have dx divided by 1 minus x. This is what you will get. So correct me if I'm wrong. So this will be k integral from 0 to 1 this is what you get, and finally this becomes, I know it's a little complicated, but this becomes the integral from 0 to 1 of x power t and 1 minus x power minus t dx. Alright, and finally we can write this as the beta function at 1 plus t and 1 minus t. So this, I don't know I don't know whether you guys remember the beta function. I talked about it some time ago. So after a lot of calculations, it's not a lot, I mean, after some calculations, this is the answer that you should get, unless I made a mistake. All right. I hope you understand. I hope you follow what I've done. If not, let me know. Do you guys follow or not? Let me know if you have questions. So in the final step, I have used the definition of the beta function, which I talked about in the class some time ago. Yeah, do you remember? If you don't, I can write it down again. The beta function is defined, the beta function at a comma b is defined like this, as the integral from 0 to 1 okay, this is the definition of a beta function, which I have used in the last step, right? Right, guys, so now can I ask you to do part D, please? Part D. This is part D, is to derive the corresponding var at P, value at rest at P of U. It shouldn't be difficult. I'll give you like 5 minutes to see if you can do part D of this question, which is derive the corresponding var at U, var of U at P, sorry, var of U at P. We are doing part D of this question. Part D, derive this one. Can you see if you can do it? This is last year's exam paper. Oh, yeah. Let me do that quickly. Then I'll give you a break. So this is part D. So to find var, all you have to do is you just set fu at u equal to p and solve for u in terms of p, right? So this will be the same as saying that this is equal to p. So this implies that 1 plus k is 1 over p. So this implies that k okay. So this implies that exponential of minus u is 1 minus p divided by kp. So u will be minus log of 1 minus p divided by kp. So this implies that your value at risk of u is minus log 1 minus p divided by kp. Alright, so that completes part. Alright, can we take a break now, please? Give you 10 minutes break. After that, can you do part E, please? Part E. Part E is the expected shortfall. After the break, you can do part E. Solutions are online, man. This is last year's exam.
Yeah, no.
Solutions are online.
Cheers. Thank you. Thank you for
Alright, after the break, can you do part E, please? Part E.
回来的时候再赚一点，可以国内保带。
我还少，估计没有必要。我自己带了4份。
装不下。
对，我都怕炸。我老怕就是他那个，就是他不是有那个什么吗？
我带了没事儿，
就是他那醋包什么的，这样子。
我带了一大袋泡面回来。
我也带过。
我也是，我带了10个真是。哇塞！你没有带吃的嘞？
我带了月饼进来还能吃。
我这月饼都被我扔了。
那我还是有点
粽子应该有点难。
可简单了，可简单了。
米和叶子都没有。
干脆不
是吗？没有叶子。你们带点粽叶回来。
这个季节已经没有了吧？你没多长时间就要回家了。
哦，对。
你这回家的时候没准已经就是快到粽子节了，那个。
粽子节。
那个端午节。
哦，板栗干黄肉粽。
哇，我觉得那个好好吃，就是那个。叫什么？我觉得好好吃，我之前没吃过肉粽子。然后
特别好吃。
我吃过这个北方的。
我觉得然后是肉挺好吃。
有的甜的不好吃，有的甜粽它甜的好吃一条，而且它馅儿特别少。
蜜枣的就一点点。
我也是枣。
蘸糖也好吃。
蘸糖好吃。
肉的也好吃。
我主要是想吃肉，主要是。
不喜欢吃肉。
你不适合吃肉，更偏心。你活该被抛弃。
这我第一次吃。
而且在自己为什么寂寞？
我去那个乌镇旅游的时候叫了一个外卖，然后早上起来说我吃个早点，然后叫了个外卖叫了粽子。
就荷叶包的那个。对。那不是那个哪一点吗？地震风好。以前都没有吃，都没有吃。
好细，我就会拿个买成那种好细。买一个那种架子。
要去干嘛？现在也有。
最全的那个中国超市。
哎，忘了。不要加入群。
哎，你微信。
因为今天赚很多钱，所以我买了个星巴克。
星巴克也是在这边很便宜的一家。
星巴克是你赚的零头。
我也买过那个盒子，来这边之后
最便宜的公司。
哦。我想喝
我去这边可乐好贵。
可不可能小罐儿？
买个大瓶的，对，大瓶的。然后我们家那个楼下是可乐好看那个。大瓶的1磅7，别喝不就便宜，就是贵。
Tesco 有可不便宜。贵。
因为Co-op和那个超市一家。反正讲买，就是我买的像。
Guys, can you do part E please now? Hello. Can you do the last part please? Part E of B4. I'll give you 5 minutes and see if you can do it. Part E is to find the expected shortfall of U. So this is the var, so it should be difficult. Alright guys. Alright, let me show you. So we want to find the expected shortfall of U, right? So it's part E to find the ES, all you have to do is just integrate from 0 to P of the var, which is minus log of 1 minus t divided by k times t dt. Alright? Okay guys, so this you can pull the minus outside, so this becomes minus 1 over p. Then inside the integral you have log minus log of k minus log of 2 dt. Now log of k is a constant, so basically you have just two integrals basically, right? So you have log of 0 to p of log of 1 minus t dt. That's one integral. And the second integral is 0 to p of log of t dt. And the last term is just simply p times log of k. So you need to just work out these two integrals, and I mean there are many ways you can do this. One way is to apply integration by parts, as we did before. So if you apply integration by parts, alright, the first thing is for this integral, it's gonna get a bit complicated. We get 0 to p, then 0 to p of t divided by 1 minus t dt. This is what you get. That's for the first integral. For the second integral, you get you get 0 to p of 1 times dt, and then we have p log k. Okay, this is what you have. Okay, now the limits, okay, taking the limits, you get p times log of 1 minus p, and this integral I'm going to write it as before. I'm going to write it as this dt, right? And then taking the limits over here, you get minus p times log of p, and the integral of 1 is p. So it's going to be a plus, actually. It's going to be a plus because minus minus, and then p log of k. Okay. And here you have two terms, right? Two different integrals. So you get you get the following. You get p log of 1 minus p. Doing the two different integrals, you get the first integral is minus 1, so it's minus t. The second integral is minus log of 1 minus t, right? And then from 0 to p, alright? And then you have p log p, So the final answer will be, I know it's a lot of calculations, so it's p log of 1 minus p minus p minus log of 1 minus p minus p log p plus p minus p log of k. Couple of things, because so this term and this term will cancel out, so the very final answer will be 1 over p okay. Alright guys, so this, I know it's a lot of looks like a lot of calculations, but it just, you have to apply integration by parts 2 times. So the final answer should look something like this, unless I made some mistakes. Alright, any questions guys? Do you have any questions on this? Yes? No? You guys okay? So this is, I'm going to do, the next question is B3, again from last year. So I will do the first 2-3 parts, and then I'll see if you do the remaining. So let me, unless you, before I go, do you have any questions on this? No? Okay. So this is, let me arrange this just a minute. This is E. This is question B3 from last year's exam. Okay. B3. Exam 2018, 2019. Okay. Okay, part A is just bookwork. Part A is define var and expected shortfall. So you just give the definition. So var, the var of x is simply f inverse at p of x, and the expected shortfall is 1 over p times okay. So that's part A. Part B is you have a portfolio made up of k investments where k is known. Suppose that the losses of the investments are dependent variables with probability density function given by this. Show that the probability density function of total portfolio loss is that. Okay. So you want to find the PDF of S, right? S is the total portfolio loss. I'm using different notation sometimes, but to remember, to find the total portfolio loss, the PDF of the port, you have to integrate you have to integrate the joint density, which is f over the region that the sum of xi is equal to s, right? You have to integrate with up to, from d sk to dx1, right? I think this is the form. If you look at the lecture notes, you will see. I mean, this is the formula I gave you some time ago, right? You have to integrate the joint density of x1 to xk over this region, right? Where the sum of xi's I from 1 to k is equal to s, right? Now, this one here is already given to us. This guy here is given to us, which is this one. This is the formula that is given to us. So this is the same as the integral over the region that of the following gamma you understand what I'm done, right? This is the formula for the joint density, right? But we are told we are integrating over this region, which is where the sum of xi is equal to s. So that means that this guy here has to be equal to s, right? Because we are integrating over that region, right? This is equal to s, right? So basically, you can pull out everything here is a constant, so you can pull out right, multiplied by the integral over the region of dxk up to dx1. So what you have here is just 1, right? But if you look at the hint, you see, if you look at this hint here, according to the hint, there is a hint for this question. According to the hint, that this must be equal to s to the power k minus 1 divided by k minus 1 factorial, right? So this becomes, so the answer is we are getting closer to the answer. All right. Now one of the properties of the gamma function is that, let me show you. One of the properties of the gamma function is that if k is an integer, then as in this case, you can write k minus 1 factorial as gamma at k. I think this is, I think I did mention this property some time ago, that if k is an integer, then gamma at k is the same as k minus 1 factorial, right? And finally, this guy here, using the property of the beta function, and I'll write down the property if I did not give that before. The property is the following: that if you have say alpha and beta, right? Beta function at alpha comma beta is the same as gamma function at alpha, gamma function at beta, divided by gamma function at alpha plus beta. Now this is a property of a beta function. So using this property, you can write this as 1 divided by the beta function at a by 2 comma k. Okay, so that completes part A, sorry, the first part of part 1, right, part 1 of B. So I should say this is part 1. So before I proceed, do you have questions on this, guys, before I go further? This is clear, guys, what I've done. I just simply used what is given to us. Right? Any questions, guys? Let me know if you have. That's okay. Yeah. So in the very last step, I used the property of a beta function. That a beta function at alpha comma beta can be written as in terms of gamma functions. Any questions, guys? Please let me know. Yeah. How are you guys? All right. You guys okay? You okay with that?
What is your role about this?
Sorry, man.
What is your role to do to the field?
The integral is all given in the question, you see. That, yeah, the last displayed equation.
Oh, right. Okay.
It's given,
Oh,
it's
right.
given equal to.
Oh, right. Okay.
Did you follow that step? What about you? You did?
Yeah.
Okay. Are you guys okay with that? Yeah. Yes. Sure. What with you, man? Are you okay with that? Okay. All right. So that's how you do the first part of part B. Now the second part. This integral is already given in the question, guys. It's this one here. The second part of B is you do it like this. Is to derive the nth moment. The nth moment. When I say the nth moment, what I mean is the following. I mean the expected value of s raised to the power n. That's what it means, right? Okay. So this will be. Are you guys okay? This will be the integral from 0 to 1 of s to the power n times the density function of s ds. Okay. Right, so this will be the integral from 0 to 1 of s to the power n Alright? Now this is, if you take the beta function outside, you get this is what you get. Now, what you have here is once again a beta function. So what you have is this is a beta function at n plus k, comma a over 2. Okay, that's the nth moment. All right. Alright, so that completes part 2. Now part 3. Part 3 is to find the cumulative distribution function of S. So you're looking for the CDF of S, which is the integral of, remember the CDF is the integral of the PDF, right? Okay, and this is, we know the PDF already, which is this is right, and this you can write as okay. Now an integral of this kind is known as the incomplete beta function. The reason is that instead of the upper limit being 1, it's an S, which is not need not always be equal to 1. So we call this an incomplete beta function. So, and the notation for that is, the notation for incomplete beta function is like this. Okay, this is the notation. This is S. S denotes the upper limit of the integral. So that's the answer for part 3. Part 4 and part 5, I will ignore them. Okay, I mean, they're not really worth doing now. So let's go to question B2 now. These are questions you should be familiar with. This one is easy to do. I'm not going to ask you to do this. This one is easy. Can you try this, please? I'll give you about 5 minutes. Can you try and do D, please? D. Part D of question B2. So it's D. Can you see this? If you can't see it, I will put it over here. If you can't see it, I will put it here, guys. Can you try part D, please? Part D.
you need to see which of the three conditions is satisfied, if any. I mean, we've done many questions like this before, so. All right, guys. Let me now. I mean, again, it's you learn by experience. I mean, you have to do. If you want to become really an expert in it, you need to really do lots of questions. So this is question B2, part D, exam 2018-19. Okay. Now it's clear that looking at the domain of X, it's clear that W of F, you can work it out, but it is equal to infinity. Now I mean, looking at this, you can it's either condition 1 or condition 2 may be satisfied. But I have a hunch let's go with condition 2 first. Alright, so because I feel that it may be satisfied. I mean, this is once again you have to be able to, like, looking at a CDF, you may be able to guess sometimes which condition is satisfied. So this will be the limit of 1 minus
Okay, like this, right? Now, as t goes to infinity, we know that this guy here goes to 0, and so is this one, right? And you probably remember one of the properties I gave you is that if you have one plus something that goes to 0 to the power something, you can write this as, do you remember the property I gave you guys? You can write the top as 1 minus b times tx minus a, and this is 1 minus b t minus a. Do you remember the property? Yes? No? Come on guys, I gave you the property a long time ago, like something like, if you have like 1 plus z to the power minus b, then it behaves as 1 minus bz as z approaches 0. This is the property I gave you. Just look, this is a property I gave you some time ago. Okay, that's what I'm using here. Okay, so the 1 and the 1 will cancel, and the b will also cancel, so you get limit as t goes to infinity of tx power minus a divided by t power minus a, which is x to the power minus a, right? Hence right, guys? Okay, is that clear? Yeah, so can you do this one please, part E? Well, we have nearly run out of time, but can you do part E? Because it's a finite range, clearly either condition 1 or condition 3 will be satisfied. So again, you can either start with condition 1 or condition 3 and see which of this is satisfied. You follow me? Yeah? Alright. Okay, let me do this quick before I go. So look, I know we are running out of time, but let me just do this one, then we will see again tomorrow. Alright, so this is B2E. It's a 2018 90. Okay, so clearly W of F is 1. Alright, so either condition 1 or condition 3 will be satisfied. Okay, so I want to try condition 3 first, which is the limit as t approaches 0 of 1 minus f 1 minus tx divided by 1 minus f 1 minus t. Do you remember this? Yeah. Okay. So now I'm gonna, because we don't know what f is, we only know the little f, not the capital F. So what the first thing I want to do is to apply the L'Hopital's rule. So if you apply the L'Hopital's rule, you get minus little f 1 minus tx multiplied by minus x, and in the bottom you get little f 1 minus t multiplied by minus 1. Okay, so you get the limit as t goes to 0. Okay, the minus cancels. Now in the top we're going to have c divided by x, which is 1 minus tx, then tx, okay, times x, and in the bottom you're going to have c divided by 1 minus t times 1, right? Now a few things will cancel. C will cancel with c, okay? As t approaches 0, this guy here approaches 1, and this guy here approaches 1, okay? So what you have is the following. You have limit as t approaches 0 of square root of t up divided by square root of tx times x, and square root of t and square root of t cancels, so what you have is square root of x. Hence is that clear, guys? Alright, so you see the trick here. Because we are not given the CDF, we are only given the PDF. So you need to apply, in the first step you apply the L'Hopital's rule to get it in terms of the PDF, and then go on from there. Okay. Alright guys, I'll see you tomorrow. Okay. Thank you, man. Thank you. Everybody sign this, guys. You haven't? Sorry.